module as well. So 8-bit timer module counts from 0 to 255, and after that the count will be 0. So this is called one counting cycle. We also have to provide a clock pulse to the timer module. So this clock pulse is coming from the main clock source. So F oscillator, let's say F oscillator is equal to 8 megahertz, and then it is divided by some prescaler that we can configure, and then this clock is applied to the timer, and the count value is stored in a register which is called TC and T0. Yep. So if n is equal to 8, then this time period will be 1 microsecond, and in one count it will provide delay of 1 microsecond, or we can also say that one tick is equal to 1 microsecond. So in one counting cycle, which is equal to 256 count, the total delay will be 256 microsecond. Okay. Now for example, let's say we want to generate delay of 1 second. So we need to find out how many counting cycles will be there in 1 second. So that can be determined by dividing the required delay by 256 microsecond. So number of counting cycle for this example, 1 by 256 microsecond, so it is 1 by 10 to the power 6 divided by 256. Okay. Now the next question is, how do we check end of the counting cycle? That can be done using the timer overflow flag. So we can check timer overflow flag to check end of the counting cycle. Okay. So this can be done by checking a register which is associated with the timer counter module. Okay. So initially we have to reset the flag. So we have to make flag is equal to 0 or reset the flag, and then flag becomes 1. So if flag is equal to 1, then it means that one counting cycle has been completed. Okay. So using this concept, we can generate any required delay. Okay. Now let's understand the structure of the register that contains the flag, and how do we check the flag if it is 1. Okay. So this is the register which is called TIFR. So we have TIFR register which is used to check the flag. So we have registered TIFR, and the bit number 0 of TIFR is the timer overflow flag. So this is the bit number 0 of timer overflow flag. So we have a register which is called TIFR, and the bit number 0 of this TIFR is the timer overflow flag. So this bit is timer overflow flag. Okay. So to check this whether it is 1 or 0, we can do an AND operation with this number 0 0 0 0 0 1. Okay. Now the result of this AND operation will depend on this flag. If the flag is 0, the result will also be 0 0 0 0. If flag is equal to 0, when flag is equal to 0, if flag becomes 1, or if one counting cycle has been completed, then this bit will become 1, and the result of the AND operation will be 0 0 0 0 0 1. Okay. So now once you understand this concept, then we can write the program to generate the required, or we can write a function for, then you can call from your main program. Okay. Okay. Okay, now let's understand programming part. So we have to do some basic configuration like selecting the n prescaler. So we have to set the prescaler value, and this prescaler value is set from the register which is called TCC R0, timer counter control register, TCC R0, and we have to start the timer. So immediately after configuring this prescaler, the timer is automatically started. The timer will start counting pulses. Once you set the prescaler, the timer will start counting the pulses. Okay. Now let's understand the programming part. So our objective is we want to write a function, which you can call from your main program as per the required delay. Okay, so for that we need to do basic configuration thing. So we have to configure the prescaler, which is done using TCC R0 register. And once we load the proper prescaler, the timer start counting pulses. By default, when you start the microcontroller, the timer counter will be in the disabled mode, or it will not counting the pulses. Okay. Now after starting the timer, we have to check end of the counting cycle, So for that we can check the flag value. So we have the flag is part of that TIFR register. So we can write a syntax like we can take a variable and we can write TIFR and one left shifted by 0. Okay. So if we can write a condition, if a is equal to 1, then do certain action, and else something. Okay. So we can use this syntaxes to check the timer overflow flag. Okay. To set the prescaler value, and we have to use TCC R0 register, and these are the bits, bit number 0, 1, 2, which are used to configure the value of n. And we have different options, like for in this case the counter will be stopped, no clock source, timer counter will be stopped, and for no prescaling divided by 8, 64, 256, 1024. So we have different option 864, 256 and 1024. So let's say if we want to configure or we want to select n is equal to 8, so we have to write 010 into this register. So we have to write 010. Okay. So we can write a syntax like TCC R0 or is equal to 1 left shifted by 1. So this will make bit number 1 is equal to 1, and then we have to reset these two bits. So we can write two syntaxes TCC R0 and is equal to not left shifted 1 left shifted by 0, and TCC R0 and is equal to not 1 left shifted by 2. Yep. So this will set n is equal to 8. Yep. So now at this point we know the basics of timer, how to configure n, how to check the flag, So now we can write a function to generate the required delay, which is our main objective. So in the function from main program, we are writing a delay function and we are passing the delay. Okay, so this, let's say it is 1 second. Okay, so it is in seconds. Okay, and then the function void delay sign int I. Okay, so first we have to find out the number of counting cycle, so that can be done. So for this example, we are assuming that n is equal to 8 and f oscillator is equal to 8 megahertz, and one counting cycle is equal to 256 microsecond. So in number of counting cycle will be the I divided by 256 into 10 to power 6. Okay, and okay, so this will be the number of counting cycle. Then we have to write a loop while count is less than is equal to j, and then we have to write a variable integer count is equal to 0. Okay, okay, and before that we have to write statement here to start the timer, which is done by configuring the n. So here the statement corresponding to the configuration of n will have to be inserted. So there will be 3 statements, so we have to select it n is equal to 8. So we have to write tcc r naught or is equal to 1 left shifted by 1, tcc r naught and is equal to not 1 left shifted by 0, and tcc r naught and is equal to not 1 left shifted by 2. So after execution of these statements, the timer will start counting the pulses. Okay, now we have to check this condition using while loop, and now we also have to check the flag as well. Okay, so if, so let me take a variable. Let me define a variable here. Int a is equal to 0. Okay, so a is equal to TIFR and 1 left shifted by 0. Okay, so if a is equal to 1, then we have to increment count, so count plus plus. Okay, and then we also have to make TIFR 0, so we have to write here, and then we have to reset the flag. So to reset the flag we have to write 1, so we have a TIFR register and this is the flag with number 0. So to reset this flag we have to write 1 here, so we have to write TIFR or is equal to 1 left shifted by 0, so this will reset the flag. Okay, so this is our complete function. This function will take values in seconds and